6.1, 6.3. Holla.
6,600.
Ooh, we've got a windy stream.
6,900.
Woo! Oh my gosh, this wind is nuts.
It said 6,942 as well.
Did it really?
Yeah, it did.
Dude, can't make it up. All right, let me put this down so it's locked. What's up, world? Actually, I'm gonna guess in our ear, my ear first. First and foremost, I think we're live over here. Check it, check. Check it, check. Mike, check it, check.
Hi everyone. Can you hear me?
Okay, let me get it over here. Doot doot beep boop bop beep beep. Oh, there we are. Hi everybody. Thank you, Nick Lovell, for sharing or for being over on the other stream. Okay, let me get you all in my ear. Do you want headphones in your ear?
Yes, please.
Okay.
Yes, please.
Let's see if we have any that are charged. Hi everybody. Hello. Hi everybody. Okay. I am joined here. Let's see, I'm gonna get Steven. Oh, is your phone recording? Okay,
My phone's...
so...
No, I'm on the live stream.
You're on a live stream?
Yeah.
Hi, live stream.
Hello everyone.
Okay, so it would be you can't connect to...
Yes, because you will need to connect to two Bluetooth devices at the same time.
I don't think my phone will allow that.
Okay, that's fine.
So,
yeah.
Unless you, yeah. So Steven is recording. Okay, here, I'll take this.
Yeah.
All right, hi everybody, hello. Steven Shard Baby is also recording live right next to me.
Yeah.
Let me get you in
Going
here.
live in a second.
Oh, you're not live yet? Sorry.
Yeah. I'm on the stream. Hello everyone.
Woo! Sorry for the woo. All right, we're gonna zoom right in here. What is the orange thing going on over there? Okay, so the higher the aperture, the more dots you see.
Yeah. Gotcha.
What is that orange thing on the ground over there?
Looks like flamies.
Right?
Yeah.
From far away, it looks like flames. I'm assuming maybe it's a JCL, JLC
Liftage.
boom
Yeah.
liftage.
Could be the alpha crane, which is the orange type of crane. The orange and yellow one.
Okay. The alpha crane.
Yeah.
Is there a beta crane?
I mean, there's the blue crane.
Blue crane.
Blue crane.
All right, we're just gonna bop this up. Y'all are gonna see all the dots. Oh, there it went. Come back. Did you die already, headphones?
Yeah, so right now we can see ship 20 has been hooked up to Crane X. That happened about 6 o'clock this morning. We can also see booster 7 on the pad. And this is, this is the first time, I think this is the first time yet that we've seen booster 7 and ship 24 at the same time.
That is correct.
Yeah. So we're seeing space history right now. That's the, this is the first ever Starship prototype, which is going to go into space.
Into orbit.
Into orbit. It's going to go around the planet. It's going to launch up from where we're here right now. We're at Rocket Ranch, which is the closest place on. Well, it's the closest place on Earth, apart from China, where you can get really close to the rocket safely.
Do they allow you to in China?
It's kind of that they just launch very close, and they just
right.
don't tell people that they're launching.
Okay.
So this is the safest place you can watch a rocket launch. Really, like, so this is the Rocket Ranch outpost, and you can find them online. You can book to stay here. That's where I'm staying right now. Staying for 30 days at the moment.
And you would highly recommend them?
I highly recommend them. Yeah, they're brilliant. Like the other day, they got kayaks, they got a boat, they got a bus. So like basically, if you're here when they're going to do the launch, it's going to be life changing. It's going to be amazing.
It's going to be mind blowing.
Like it's all going to be like the launch is going to happen. The roads are going to be closed. They're going to they're going to bus people over here. There's going to be a boat.
I'm trying to get the
just in
focus
case you can't go down the road. So it's all ready. It's all set up. And yeah.
Shard baby, everybody.
Hey, yeah.
There he is, giving an intro to the stream.
Yeah. So this is.
What do we think this orange thing is, y'all?
July the.
Oh yeah.
6th. Yeah. July the 6th, 2022.
Is it the 6th?
Yeah.
July. Okay. Greetings, everybody. Welcome back to another live stream. Joined here by Stephen Shard Baby, the Shard Baby. He also has his own YouTube channel. I encouraged him to go live on his channel as well. Next to me on his phone, it's underscore? No, it's just the.
Yeah. No, it's Shard_baby
on Twitter.
Yeah.
But on YouTube, it is the space Shard, SHARD, space baby, BABY.
Yeah.
Here we are. I appreciate you all being patient with me while I took some time off I'm still grieving Stella's loss. Stephen actually did something really important and special for me as he rode along with me while we went to go pick up Stella's ashes. We drove all the way to McAllen, which is where I took her that day, and he rode with me and held her on the way home, and I just really appreciate that, Stephen. So thank you so much. I keep telling him, just thank you. I don't know how many times I've thanked you.
It's okay.
I couldn't have done it alone, no way. So let me get that in the ear.
Yeah, so Stella's back home.
Stella's back home.
Stella's back home. She's
right above my bed.
The trailer.
Looking out the window. She loved the window. Trying to get you in my ear right now. It's not wanting to work. Oh no, big wind. Ooh. Gosh, all of these are dead. Are you freaking kidding me? All of my headphones are dead.
Okay, I'm gonna set up my live stream. It's the third live stream I've done because of course,
holy wind gusts.
Windage. Because yesterday I woke up at 6:30. I was at Rocket Ranch, and basically I saw that Ship 24 was basically already on the road. So basically, I just kicked myself out of bed and got here in like 22 minutes, and got straight onto the road, and Ship 24 was rolling. So I did a live stream. It's a bit shaky. You might want to see that after Jessica's stream. It's my first stream, but then I did another one later in the day when there was a mega event at the orbital tank farm, and this is the third time I'm live streaming. So
having fun?
Yeah.
No pressure?
Good.
That's a joke. You're doing great.
Yeah. Thanks for the tripod.
Super proud of you.
Yeah, it's not going to be shaky this time.
There's a certain point where there's just nothing you can do about it.
Yeah. Possible testing. So there's possible testing at the launch site today because they've closed the road. This morning they lifted Ship 24 onto suborbital pad B, which is where it's.
You don't see the Shard babies live on.
Not yet. Yeah, I haven't gone live because.
Oh, you're not. Okay.
Yeah.
Okay. All right. He's not live.
It's like
just kidding.
this is me doing
Okay.
several
You want me to
things at the
take your
same
mic?
time.
I think they think you're talking. Who are you talking to? You're talking to.
Oh, I'm talking on your stream.
You're talking to our stream.
Yeah, that's
Okay.
what
All
I'm
right.
doing.
All right.
Yeah.
Okay. Sorry. I thought that you were talking to your stream. Okay.
Um,
All right, everybody. Shard baby. Steven. Let's get Shard in the chat. Sorry, I don't have it in my ear because all my freaking things are dead. So. Crackles. I'm a crackle. Yeah. Really confusing. All my headphones.
That's why I didn't start my stream, because I'm gonna tweet out your stream first.
Because of what?
I'm gonna tweet out your stream first.
I didn't hear what you said. But
That's why I didn't go live first, because of course I'm gonna tweet out your stream.
oh, I appreciate that.
Yeah.
Thanks. You, don't worry. Yes, I'm good. All right, this needs to charge. So I have absolutely no idea what we're about to do today. Will it be live on YouTube or Twitter or both?
Yeah, just YouTube.
Just YouTube is the answer.
Hey chat.
And I do not have any audio in my ear because all my headphones are not awake. They are sleeping.
Make sure I copy the link, because sometimes I tweet it out and I forget to put the link in it. And also, if you're...
Ooh, thank you so much for subscribing, Zundiki. Zundiki. Hi, Jose Casadin. Hola. How far is the camera set up? I think it's 4.1 miles, I believe.
Yeah.
4.1.
About 4, yeah. Still just
Crackle.
outside the exclusion zone, I think.
Okay, so, oops.
When
this
it's going to be
keeps
exclusion zone.
flopping.
Which is going to happen when there's an orbital launch. It's going to happen very soon.
Okay, so right here we're looking at ship 24. Hard to see from this angle, but they actually do have a SpaceX X on it, and they also have an S24, indicating it is ship 24. Can we have a mic check in the chat? Can you say mic check in the chat?
Mic check, mic check.
Thank you. Okay, so this is ship 24. What was that? That was the tree. On my hat. That's what it is.
Rare trees, yeah. I think
Trees.
trees out here.
I see a grackle. I'm a grackle. I'm a grackle. There it is. Grackles be crackling. Oh, maybe that's an eagle, actually. What do you all think? Yeah, so I have no idea what's going to happen today. It's possible. Actually, Shard, Steven had thoughts on what maybe could happen.
Yeah.
Are you willing to share those with us?
Yeah, sure, because basically, I've been here for the last week, and we've seen a lot of action at Starbase recently. In particular, one thing I've noticed that's kind of indicative of what might happen today was that, well, we saw, of course, last week, we saw B4 move from the launch site. And the thing is, they've got B7.1, they've also got EDOME. So possibly they've moved Booster 4 out the way. This is why Booster 5 moved inside the Mega Bay to be scrapped, because it wasn't needed there. They moved Booster 4 out of the way so that they can do some testing. Because looking at EDOME, it's very similar to SN7 and GSC4.
Windy.
Windage. Windy.
You're doing great.
Yeah, and what's it? Yeah, and the thing is, EDOME is a similar test. Looks like a similar test tank because it's in exactly the same place that GSC4 was placed. But the thing is, it looked like B4 was too close, so B4 moved out the way because it's likely that this is a pressure test where they're basically going to fill the test tank with inert liquid nitrogen, and they're going to increase the pressure inside the test tank until it gets to the point of structural failure, because that's currently they've only done simulations, and there's only so much you can learn from simulations. So by doing it in real life, they're going to discover, they're actually going to find out for the first time what's the limit, what's the structural limit of this new design. Because the E-Dome, it's one of those experiment. Well, we don't know why it's called E-Dome. It could be Elon Dome. It could be experimental dome. It's probably Elon Dome because maybe he invented it.
C'est possible.
Yeah,
it's possible.
It's possible. Well, there are also a lot of other talented engineers in SpaceX who could have come up with the same thing. It's a new flatter dome, and the advantage of the flatter dome is that you have less material, and also it takes up less space. Which is going to be really good because if you look at the way that the Starship nose cone is designed, and the Starlinks are designed, the Starlink V2 is about 7 meters wide, and the thing is they're quite limited in the amount that they can put in there because of the geometry of the nose cone. But back to E-Dome. E-Dome, it's a brand new design of dome. It's it's a new geometry. It's going to behave differently under pressure, so they've got to find out the limits. Yay! Woo!
They're giving you love in the chat, BT Dubs.
But yeah, they're gonna. Because it's a different design, that it's going to have a different limit. So by they don't know that limit yet because they haven't done it in real life. So by testing it here and by increasing the pressure, basically it's going to it's going to fail. But they'll know once they know that value, they will know at the point what pressure, what's the limit of the tank, so that they can then put a safety margin on the suitable pressure that's.
Good job, dude.
It's going to be okay. So basically, we might see it pop. It could be like GSE-4 where they tested it before and then they tested it to its absolute limit.
Will you look through here and tell me, just try not to move it? If you can look through or just look at that, does it look like the orange is getting bigger or the same? Oh, here they come.
Yeah, oh, hang on. There's two.
What is that orange thing, y'all?
It looks like there are two, actually.
I'm going to step...
There's one to the right of the OLM, and there's also one to the left between ship 24 and the tank farm.
Hi! Yeah.
Yeah, possible that
we're live. Say hi to YouTube.
They are just...
Hi, YouTube! I don't know if I'm still in. Woo! Woo!
Yeah, I think from here you can possibly see... I think that's B7.1 in front of the orbital tank farm. And then it looks like the Raptor stand is to the left of those trees.
We have a turkey! Oh!
Yeah, it could just be the lifts. It looks like the same colour orange as the alpha lifts. And the thing is, I was up in the dunes yesterday, and the thing is, in preparation for the orbital launch, they are kind of finalising things. And one of the things I noticed is that they were concreting over the berm. And basically the berm is like it's like a retaining wall structure, but it's not. It's which is kind of like it's an inclined kind of hill, and basically when the launch happens, a lot of sort of sand and dust and whatever is going to basically be kicked up in the it's just going to be scattered around the launch site from underneath the engines, because the power of the engine is just going to force all of that.
It's going to go.
It's going to
go like a dinosaur.
Yeah. So.
Or a big raptor. Raptor. Oh, hi, puppy. Oh my goodness! Look at the dig. Oh. Oh, is he an old man?
Yes.
He's so sweet. Is he afraid of anything?
He is afraid. Well, he's afraid of everything, actually.
Where is he? That's okay. That's okay.
I don't
Big
know.
hat?
He really
Like a big hat?
I don't think so. It's more like bags and plastic.
Understood. Stella was afraid of this too. Hi, sweetie. Hi.
He loves women.
Oh, does he?
Yeah.
He's like, your hat is big. Come here, sweetie. Hello.
Hello.
It's
It's like a doggy.
Hello. Oh, it's okay. We'll be friends later.
Yeah.
Right, yeah.
Yeah, it's okay. What the heck is that?
Dog. It looks like the lifts.
Okay.
Yeah. Okay. What was I talking about? I was talking about. Then I got distracted. We got distracted by the doggy.
You got distracted by the dig.
Doggy.
Dig. He calls it diggy. I say dig.
Okay. Yeah. But
You're doing
basically,
good.
the berms are there to protect the other equipment at the launch site, so that when all this stuff basically gets blown, I mean, the rocket's going to be really powerful. Stuff's just going to be moving fast, and you don't want that to be hitting your tank farm. So you need some sort of wall to protect it, and that's what the berm is. But the thing is, before you might have seen previous Starship launches where basically all of this stuff or sand just goes. You just see a huge cloud. Basically, that's what they're trying to protect those high-speed particles from hitting the equipment. So this time they've decided to concrete over the berms, so that
Thanks, Perpetual.
yeah, I mean it's just being
Paul.
more tidy.
Ooh. Ooh. What's up, everybody? Hey, hey, hey. Jessica Kirsh here, coming to you live from the Rocket Ranch Outpost. Shout out to Rocket Ranch for hosting us all the time and giving us these incredible views. I'm going to put it in the chat. Hey, Robert, I am at the Rocket Ranch Outpost. Head over to Rocket Ranch Boca Chica.com. Water deluge sprayers just below engine bells to wet the pad concrete and muffle the sound of the engine blast, says Michael Maxey.
Yeah, that's good.
Yeah. What's up, Paul? Hey, hey. Thank you, everybody, for showing up. It's a big deal. I realize that there's lots of specks on the glass in between here and the launch site on my camera. I understand that the heat condensation is pretty gnarly today, and also it's just hard to focus, and I also don't have you in my ear, so I can't tell you if I don't know what we sound like, so yeah. Oh, cool, Robert, that's awesome. And you said that you had a picture at the ranch. That's so cool. You stayed there for 3 days and met David as well. Cool. Hey, Ken, I see you there in the chat. What's up, my friend? That's so cool. So we are just chilling here. I'm going to go for a time, and then I'm going to go for a weather Boca Chica and see if that shows up. Hi, bonsoir. Hi from France. Hello, Michiel Lavigne. There's a lot of Lavignes. Is that just a very common last name or surname? You took a picture of the ELS Launch Complex 39 from the shuttle days. I can't believe they hung it up. Yeah, that's really cool. What's up, Perpetual Nerd? I see you there. Hello, Mr. and Mrs. Perpetual. Team Seagull, what's up, Whoopi? Oh my gosh, Whoopi, you have a picture. Uncle Yukon is here, and there's Veronique Lavigne. Are you all the same? Hi, Veronique. Bonsoir de France. What does gros bisous mean? Good old, what's up, Todd Taylor, Texas? That's fun to say. Lots of love. Oh, I love that. Thank you. Dave S. is here. Doodle, I see you coming in with a heart. I appreciate you all so much. It has been it's been a rough 8, 7, 9 days. But thanks, you all have provided a lot of love, and you've allowed me to grieve publicly. Even just sharing like a heartbreak emoji is helpful. So thanks for just sending so much love. We've got Nick Lovell in the chat. Oh, thank you. Oh, thanks for adding the HTTPS. All right, let's just take a look-see over here. Live stream vibes. Really looks like an orca whale today. I can see the orca flippy flappies.
Eaglage.
Yeah.
Saw an eagle.
Yeah? Is
Yeah,
that what was flying
Uncle
above?
Yukon saw an eagle.
Eagle. Wow. Fly like a bird and fly away. I don't know where my home is.
Hey. Thanks, Nick.
Yeah.
Yay. Linked,
All right, I'm gonna have to do a battery swap.
swappage.
Swappage. All right, everybody, it's going to go, the screen is going to go black, the audio is going to go away, but I will be right back. All right, stand by for all call. Here we go. 3, 2, 1, beep. Eek.
Eek.
It's okay, puppy.
Doggy.
It's okay.
Doggy.
Dig. You're welcome to have the chair.
Oh, yeah,
Even
we
though
got
it's
chairs. Yep,
hard to sit down when you're all
that's cool.
live streamed up.
Yeah, I found like the other day, it's like there's nowhere to sit down. There's nowhere. Yeah, and I was here yesterday. I was literally out there all day. It was really hot. I got a sunburn. You have to drink lots of water. Your water ends up being warm.
Oh yeah.
And yeah, I think I didn't even last half a day because I decided. I mean, we're all of us that were kind of keeping an eye on Ship 24. We're just like, we can't do this. It's like, so yeah.
Anna.
Jessica's doing all the work. Yeah, it's doing really well to
thanks.
just do all of this in this weather. It's really harsh out here, so yeah, send over some support, send PayPal, send a Venmo.
Oh, thanks.
It really helps because like
Thank you.
it's tough out here. I'm just saying that from personal experience now because yeah, it's.
Greetings from Billings, Montana. What is up, Bob Brink? Oh, I thought you had a registered trademark on your name, but no, it's just my own spit on my screen. Right over your name. What's your dog's name again? What is it, Mac? Mac? M-A-C? Ah, hi, buddy. You have a really cute beard. Hi, sweet. Yes, it's okay. It's okay. He's saying hello. The stream says, hi, Mac. He's sweet. It is windy, folks. Oh, Anna wants to know who that is.
Yep. That's,
Put it in the chat. Hey, Mr. Smee. Thanks so much, y'all, for your patience. I see 100 people here, 83 likes. Can we make those numbers match? Can we smash that 83? Can we surpass 100? Oops.
Yep, I'm here for 30 days now. Then I'm going to go back to the UK to graduate. And
I'll be
then
right
I'm
back, everybody.
planning to come back for another
Alright, so it's just
39
you.
days. So I'm going to be here for, hopefully I'm going to be here for the launch. Okay. Hey! Oh yeah, we have vintage. Thank you, Nick Lovell. We're seeing some vintage from the orbital tank farm. Looks like yesterday there was a huge mega event at the orbital tank farm. We're seeing that this morning. We're seeing that. I think we're seeing something very similar right now, which is probably indicative. Yeah, it's probably a good sign that they are probably going to test something. Maybe on B7. I mean, B7's hooked up to has been performed a cryo test, and it's, even though it's still got a ventilation tube inside it, ventilation tube, and there's still some scaffolding on the side of it. So I think that's why we might not see some static fires on B7 until that's taken away. Yeah, it looks like things could be starting up. So hopefully we see a test on either B7, B7.1, or the experimental E-dome tank. Probe stack. Yeah. Yes, that's. I think that's right. Yeah. Thank you, Michael Maxey. That's we're seeing. Yeah, it looks like we are seeing venting from the smokestack, which is the smallest. Is a smaller stack, which is in between the methane tanks and the main propellant tanks at the orbital tank farm, which are the tall ones. There are 8 of them. Of course, we have. We have the. On the right hand side we have liquid oxygen, and then the 2 central ones we can see right there, those are liquid nitrogen, and then we can also see 2 empty methane tanks. Oh, actually no, the second one to the left is the water tank, and then the liquid nitrogen is one behind it, and then we have 2 tall methane tanks which are supposed to be methane tanks, but they're empty because possibly they weren't. They designed them and they built them, and it turns out that they weren't made to regulations. So basically, they had to extend the tank farm to the west, which is closer to us in frame, and the smokestack is right between the methane tank and the orbital tank farms. So that's what we're seeing, and actually, because I just thought about it, we could actually see some we could see some test tanking with E-Dome, because E-Dome's quite close, and okay, yeah, okay, so Dave Avery is saying that the empty methane tanks are now being filled with water.
Ooh.
Yeah.
Oh yeah. Let's methane tank it out. Oh, look at that. All right. Oh, I'm like, why can I not see? It's because I don't have contacts in. That's why. So I'm officially out of contacts, and I called today, and my order hadn't shipped because I ordered the wrong contact lenses that were not written on the prescription. Wah, wah. Can I get a wah wah in the chat? A wah wah. So if it's out of focus, please let me know in the chat. That'd be great. I'll try to do the best I can. Do what you can where you are with what you have. Are you live?
No.
No, that's okay.
Yeah,
that's okay.
Because
Thanks for holding over the stream.
that's cool. Yeah. Hey, thank you, Moonbeam Bruce.
Oh, Moonbeam Bruce.
Woo.
Like this, go like this.
Yeah, this. Woo.
Don't want you to hurt your wrist.
Yeah.
Thank you, Moonbeam Bruce, for that $50 Canadian super chat. Thank you, thank you, thank you, thank you for helping pay the expenses. That was a big deal. Thank you so much. Thank you. Thank you, thank you, thank you. Oh, thank you. Lots of venting. Vintage.
Vintage.
Tons of vintage.
Because I'm on my phone, I have to type Moonbeam Bruce and momentary say from reality on my phone.
Yeah, typing it. It's tough, right?
It's long. Yeah.
Yeah.
It's a great name.
It is great. It's just tough to type out for sure on mobile.
Yeah.
Thank you.
Yep, CH4 is methane. Yep, because it's carbon and hydrogen. And the really cool thing about carbon and hydrogen and oxygen is that basically you can make that. Yeah, CH4 is methane and O2 is oxygen.
Wind.
And
Also wind.
yeah.
So much wind.
Basically, you can create these. You can separate the gas. You can separate the fuels. So it's liquid methane,
Oxygen.
liquid oxygen that's in the tanks. But you can actually create it by heating carbon dioxide and water. So you've got H2O, which is hydrogen and oxygen, and you've also got carbon and oxygen in the carbon dioxide, and you heat those together, and you're taking carbon dioxide out of the atmosphere. You're combining it with water.
X Prize.
It's amazing because it's literally.
Like, can you say that one more time?
Yeah.
So if
So
you
like
heat.
if you heat carbon dioxide with water, you're creating the methalox fuel. So
Okay.
when Starship burns,
Heat carbon dioxide with water.
water.
Okay, yeah.
it creates methalox fuel. So basically, it's carbon neutral in a way. I mean, it's kind of carbon neutral because you have to have some energy to heat them together, because basically, you have to put some energy into the system, but then you get that with everything else because you can't really have a perpetual motion machine. You have to have some energy in it to start the reaction. But yeah, it's much more sustainable than RP1, like the fuel that they burn in the Falcon 9s, and it burns a lot more cleanly too. And the thing is, it burns. You then have the exhaust from the rocket. It's a Sabatier process. Yeah, thanks very much, Paul. The Sabatier reaction, which is what they're going to use on Mars to extract methane and oxygen from the planet so they can then refuel the Starship. But this is a really good thing because with Starship, it's eventually we're going to have point-to-point. And the thing about point-to-point is that it's like an aeroplane goes around the planet, and it goes from London to Australia. I'm doing a local example. I can use a local
In
example.
20 minutes or something?
And the thing is, because a rocket is going at orbital speed, it's going at more than 17,500 miles an hour. Basically, you're going so much more faster than if you're on a plane. Planes can do something like 400 miles an hour. So you go around the planet at orbital speed, so you can actually get from LA to, I think it's LA to Tokyo, which is on opposite side of the globe. So one side of the planet to the other in 50 minutes.
What?
50 minutes. I know, and it's going to be a game changer, because if they do this, you basically have a system which does the same thing as aeroplanes. So this, you'll start seeing commercial flights that take you from place to place on Earth, which will eventually phase out aeroplanes because there's going to be so much more advantages. And yes, of course, there will be a costing, but remember that aeroplanes used to be much more expensive when we were kids, or 100 years ago. It's just going to take more and more and more innovation, and then eventually Starship's currently projected to cost $2 million per launch. And it's going to be used so much, and of course they can create their own fuel by using the Sabatier reactions, so that they don't need to truck propellants from lots of places on the globe, which also uses a lot of fossil fuels, a lot of resources, whatever the vehicle is powered by. That's why it's good that we've got Tesla, which is isn't using up resources. So the fuels that we're taking out of the Earth, they're a resource that can't be replenished. So this is a completely sustainable system, because you can create your own fuel at the launch site or close to the launch site, and you don't need to truck it. You just need a pipeline. You don't need to truck it hundreds of miles, which is also saving on transport. So basically, your transport services can be used for what transport services really should be, is moving basically, food, water, whatever goods that are kind of the first priority, and same in that making transport accessible to humans. Why am I saying humans? So used to saying humans. Transport, accessible to more railroads and systems, will be there for people. And the other thing is that Starship is good for long distances, where you can basically go from each country to the other. It's just me. Okay. That's next on it. So you have Starship, which is good for long distances, but you also have Hyperloop, which is amazing for short distances. So there's a current proposal for, or it's just been, there's not really a serious proposal, but there's a proposal that said if we build a Hyperloop train between London and Edinburgh, which are basically two cities in the UK that are 400 miles apart, you can get from city to the next place. You can get between London and Edinburgh in only 20 minutes. And the thing is, this will completely change travel, because if you have an electric, it'll be an electric system, and it's also transporting people.
Electric boogie.
Yay!
Sorry.
Yeah.
Gotta add some song in there.
People are asking me to.
What?
They're asking you to introduce me.
For show.
Yeah.
Oh,
Ooh.
hello. Let's see, here's my mic. Hi everybody, sorry I stepped away for a second. Let's see, let's see. You're cool and young and optimistic about the future. That's
Yay.
right. That is right, Paul.
Thank you, Mike.
Woo, woo, woo. Bone dipping. What's up, Danielle? Please.
Yeah.
Okay, Galveston County Mike for sure. Thank you for that $5 super chat. Jessica Kirsh. Jessica, please reintroduce your guest. Cheers from Galveston County, Texas. You got it. I need to do my inhaler. This is Steven. I don't know your last name, but his name is Steven. It's Stephen, Steven, and he goes by The Shard Baby on YouTube, and then also on Twitter, he is Shard_baby. He's from the United Kingdom, from London.
Yep. London, UK.
London, UK.
That's where they built the Shard when I was a kid. Basically I followed the construction of Shard every single day when I was really young. So it's like watching construction projects. I was literally watching it every single day. Like people were documenting this project.
And some water.
Thank you for some water. I was documenting this every single day. So like it's this thing that
Need my inhaler.
it's just what people are doing at Starbase. So like it's really exciting to see stuff that's happening on Starship, where I mean Jessica's here. Lots of us are here. Basically, we're here to watch history happen, because the most amazing thing about seeing the Shard being built was that it changed every single day, and it was seeing them eventually accomplish something. And I still look. I mean, it's been 12 years since the Shard was really going up, it's now. I still look back on it, and I still remember like dates and when things were happening, and it's kind of cool. You can say I was here, and we're watching Jessica Kirsh's live stream, and we're seeing Ship 24 and Booster 7, which are going to be the first orbital prototypes. It's this point in history that's never ever going to happen again. But Starship hasn't even gone to space, and we're seeing history happen right now. And it's why I'm here. It's something.
Just to clarify, everybody, Steven came here before he met me. He came here out of his own will and saved up the money and flew over so he could see this for his own eyes. And you got here for the first time. What date did you get here?
I was here on December the 27th. I flew in, and then really December the 28th was my first day in America.
Okay.
Did a lot of stuff with my first day in America. The road closed, and then eventually the road opened again, and went back to the launch site, and there I met Jessica. And I did my
What day was that?
interview. So.
Oh yeah, there's an interview.
Oh yeah.
The Shard by the interview.
That was really just because I had to see this, because and that's why I recommend going here, because it's seeing something because this is such a special place. This is a special point in history, and I realised that I've got to see it. I went there because I was thinking I have to see this now, because I just want to be there. I want to take it all in, because right here they are. Yeah, bless you. Bless you.
Bless you.
Bless you. Yeah. because I realised it's not going to be the same again when they launch the orbital prototype. So that's why, it's like do what you can where you are with what you have.
That's right.
So
Brown, thank you, Les Brown.
Yeah, so I just went here, just saw it, and then I think this year I was kind of realising, I've got to be back because it's just so cool seeing this, and I love seeing places change. It's like when I was watching the Shard, it was really good because every single day something different was happening, and then like a year later, the construction had developed to this point. Was like really, it was really good to see it at the beginning and look back and say, hey, look, they still haven't got the cladding panels on the top of the mega bay yet. I was there. I saw it. And you can see the same thing here. You can see it through Jessica's streams, and that's the most amazing thing, is that we're on the other side of the world. And I spent the last 6 months in London, and in London.
You have a question?
Yeah.
From Carrie Hoggard. I like your mini vids on the Shard and the Queen Elizabeth II tube line. Will you be doing any coverage on the HS2?
Oh wow, yeah, thank you very much. Yeah, thank you very much, Carrie. Because I went on the Elizabeth line the first day it opened. I'm planning to sort of look at each station. I do know stuff about HS2. I could go there. I could go on the sites. It's a big project. So yeah, I could have a look at that.
This chair's broken.
The thing about HS2, because it's a line between London and Birmingham, and basically it's a brand new high-speed rail line. It's a brand new line that's going through a lot of Britain. Cool facts about the HS2 is that they have this barcode pattern, which basically shows up on sort of structures related to HS2, and the barcode is supposed to spell out HS2 in some code. I'm not sure what it is, but it's something to look out for, because basically there's a lot of challenges associated with putting a barcode in concrete, because it's like this ribbed pattern, so they have to have this special formwork, and it's more expensive, and there's a big difference between having a flat wall and a wall with ribbed paneling on it, so it does make it cost a lot more. And this barcode pattern is everywhere. It means that you train up engineers, because it's a challenge to work on that. That's something that's something unique about HS2, which probably might not know, because that project is something like 106 billion now, or like it was. It's like the biggest project that's happening in the UK right now. It's
actually doesn't sound like that much. I know it sounds bad.
I know it's a railway line between London and London and Birmingham, which is just 200 miles.
That's a big.
Yeah,
that's a big dig.
It's like but I think they've done Crossrail, which costs 20 billion. Well, it's supposed to cost 15 billion, but it was a kind of cost plus thing, a bit like I'm not sure if it's the same thing that they do with the shuttle, or the shuttle with the SLS, where basically you've got a whole bunch of contractors working on one project, but the thing is, it can kind of be. They are competing, but you kind of have. You can kind of have contractors which are working together, and sometimes there can be some friction and
that makes sense.
It's like they're kind of companies joining together, but really they're trying to beat each other at what they're doing. So
Because they all want the
they all want to say, yeah, we've worked on.
They want to stay employed.
We've done this. We've been part of this project, but it's kind of things go wrong on these projects, and like there was a bit of an overrun with Crossrail, and yeah, it's kind of funny because it does give people jobs, and of course jobs pay taxes, which then is good for the current government. But the thing is, like, you've got a project that costs 20 billion, and there are better ways to do it, basically. To build
What do you think about using a boring tunnel?
Yeah, they could have just used a boring. That's what I'm thinking. Is that
think about how many different things can be made
better? Like Starship is like trying to make. It's a huge leap forward, and these are the innovators. These are the companies that do research and development and mean that we do make progress. And the thing is, SpaceX are going so far forward that they're kind of paving the way for, and then other companies have to do the same thing because they're doing things in such a in such a useful way. Like having, like, I in my opinion, I'd say having a hyperloop between London and Edinburgh would be much more beneficial. Building the hyperloops now would be much more beneficial than building a railway line that's only going to last 120 years. Because the thing is, with the design life of these things is design life for concrete. It's design life is only 120 years, and I think that concrete is being
concrete.
Concrete, yeah.
That's a thumbs down, everybody.
Yeah. it's
thumbs
taking
down,
resources.
thumbs down.
It's taking resources from the. It's when they test the engines. Oh, yeah. Okay, somebody's talking about the statifier. Yeah, we could see statifiers soon, which is cool because.
Not today, though.
Not today.
Because we do not have an overpressure notice, and you notice that there's a lot of scaffolding still.
Yeah, the
around
scaffolding
on the
Crane X is still attached to Ship 24, and also there's scaffolding and there's a ventilation pipe inside of B7, which is why I'm thinking they're testing the other tanks. But the thing is, they're setting things up so that they're ready. They're going to go. So, like, probably tomorrow on the 7th of July, they've got another closure. I think they've got another closure on the 11th of July, which is next Monday.
Which is interesting that they're skipping Friday.
Yeah,
I guess maybe not.
Maybe they're quite limited on the number of days they can do a week.
Maybe.
But yeah, with what space, the thing is, SpaceX are making it's like how SpaceX are making a rocket reusable. You just don't waste an entire rocket. Like, I mean, yes. I mean, these last few launches they were there to make progress to like get to the moon and stuff.
Nick Level came in, says, at the Shard Baby, the current estimated cost of HS2 is between 72 billion British pounds, is that right?
Yeah,
and
98 billion.
98 billion British pounds at 2019 prices, compared with an original budget of 55.7 billion British pounds in 2015. Ooh, yeah, Mike Maxey, thanks for that dot in the chat.
2015 prices, it's already running over budget, and they could do something different on the project. That's like, I mean, this is
Tommy. I see you.
This is the thing. SpaceX is doing such a good thing to create a fully reusable rocket, because then all the other companies have to do the same, because you're just wasting money if you're if you're not reusing your rocket. You're also wasting resources. So this is the thing. This is what I'm saying about HS2 is that it's using concrete, which only has a design life of 120 years. That's going to have to be replaced. That's going to have to be maintained. But the thing about concrete is that you're taking resources from the planet which can't be replenished. and 33% of the CO2 of the planet goes into making concrete. So if you have a project that can be built hopefully on. I mean, the idea for SpaceX is that they're going to Mars, so ideally they'd have a fully reusable. They'd have.
Wait, did you all know that 33% of the planet's resources goes to making concrete? That's nuts. That is a crazy number. What?
Yeah. Yeah, Nick Lovell.
All right, I'm trying to get it focused, yeah.
Sounds like Boeing is the main contractor for HS2 then. Yeah, it's weird because like you can stick with the way that you're doing things, like making things. You're sticking with the way that you know how to make things.
Windy.
And it's more risky when you do something new. And of course, SpaceX are a company that's willing to take the risks. But the thing is, this is it's a necessary step.
Short-term pain, long-term gain. Short-term costs, long-term
Long-term investments, yeah. Because
long-term
you put
return.
in all the funding for a fully reusable system. I mean, this is costing SpaceX billions. It's costing
billions and bajillions.
But this is going to make such a difference because you know that aeroplanes put so much CO2 in the planet, and the thing is, and the same thing with making concrete. It's not sustainable. You're putting more and more. You're just taking, and the thing is, when you move to Mars, you've actually got to. It's got to be a self-sustaining city on Mars. So they'll have to think about what they're going to bring there first. Which is going to mean that we can use like material, like what sort of materials we're going to build out on the red planet. I mean, the good thing about Mars is, I mean, it's kind of, I'm saying the opposite of what I'm saying we should do on Earth, but yeah, it wouldn't be so bad on Mars if you're filling the atmosphere with CO2. Because the atmosphere is only 1% of that on Earth, but that really doesn't apply here on Earth because.
Wait, sorry, I want to hear what you just said. 1 second, let me just project. Beep boop, beep boop. Okay, one more time. What'd you say?
Oh yeah, what was I saying? Yeah, it's like. But the thing is, you can't really. That's not a good idea on Earth because. It is heating up our planet, and it's what you change and what's possible to change, and you can change. In order to not release so much CO2 into the atmosphere, and ideally you can bring it down to zero, and that's the goal. Because even if you have a concrete and they're saying, oh look, we got zero concrete. It's complete rubbish because the concrete they say, oh look, we're reducing the amount of CO2 that's being made into the concrete, but that's only like 10%. But 10% less of 33% is only 3.3%. I mean, it does make some difference, but not the difference you can make if you build stuff out of more sustainable materials, such as stuff that we've already got, timber and stone. Timber, yeah.
It's going up. We should use timber.
Because timber is, you make it from trees, and this is what I think Elon could do for Mars, is that he could bring.
Should we put you on camera for this part?
Oh, I could, yeah, because
all right.
This is basically
short interview time, y'all.
This is my interview.
All right, let's just take a pause here for a second.
From the zoomy, I'm going to take the zoomy lens out.
All right, we're going to do another shot interview.
Wear your sunglasses.
I've got to switch my lenses.
Are we mic check? Mic check. Is it too windy?
Mic check in the shot. Okay. Shirt has an innovative new. Hold on, I'm going to put a different lens on.
With a different lens, otherwise I'll just be really zoomed in if I just walk in front of that right now. All
right, let's change over. Woo Oh, it's windy. Holy shnikes. It is windy. All right. Stay there, stay there.
Oh no, I'm going in front of the zoom. I said I did what I
I think that...
said I was not going to do, which is walk
All right,
in front
everybody,
of the
take
zoom
this
lens.
view in because we're going to switch lenses.
Sorry if you just saw a massive version of me through the
It's
zoom
all good.
lens.
Okay, let's sit you down in a
there.
chair.
Yeah, I can stand up.
You want to stand?
Yeah, I can stand.
All right. Just as long as you stay in one place.
Yeah,
You think you can do that?
This is what I want
I
to
know I
talk
can't,
about.
so that's fine.
I mean, you can see everything here.
You know what? What the heck?
Yeah.
Let's have you back up and see if we can get you on this lens.
Get me on the right at the back.
I can see your face.
Yeah.
Yep.
Hey.
Keep going back.
Okay.
Back.
Right.
Oh, yeah.
Yeah.
All right, stay there.
It's hotter here.
Are you okay in the sun, though? You got
it's in the
sunburn.
sun. Maybe. Yeah. Because you kind of see yesterday I got really badly
Let
sunburned.
me move this.
Wear one of these. These things are called neck gaiters.
They're the best.
You can just buy them online, and I really recommend buying one before you get here because
Hold on, I can't
the sun
see.
is.
All right, I just have like your face, and that's it. So if you want to go over here, if you want to be in the shade.
Okay.
All right, so here is, who's ready for a shard interview, everybody? Woo-hoo. All right, just your face right now, like right real close up.
Okay. Will it work if I have a close up of my face?
It will work, it just is going to be like right, it's too close.
Yeah.
Stay there,
'Cause,
stay there, stay there. I'm going to have to back up. Oh shit. Where are you at? Don't move, you can't move.
Okay.
That's why I was gonna sit you down.
I just stay here. Yeah.
You sure you don't want to sit?
Yeah, that's fine.
Okay. I literally have this much of screen for you to move around in.
Okay.
That's it.
Yeah.
And you're not, hold on, you're not in focus yet. 1 second. Ah, yeah. You literally.
Okay. I'm literally just in there. Okay.
Let me just put this behind you,
Yeah.
just in case you.
Just in case. Yeah. Probably. Yeah. Okay.
There you go.
Make sure I stay in shot.
Gotta stay in shot.
This is the zoomy lens, which is.
We have your face.
Yeah. Cool.
All right, everybody. Wait, before you go, hold on. Let's get a.
Oh. What if I explain things with my hands?
It's not gonna show. So.
I'm not gonna show.
Oop, hold on. I need to put another tripod out. This is the problem.
Yeah. It's
My
what we,
second
do what we
camera
can
is
where we are
done.
with what
Hold
we
on 1
have.
second.
Lots of.
I need. All right.
There's a lot of planning that goes into a live stream.
Yes, there is.
So this is.
All right, that's as far back as I can get, and now I just have your head and your shoulders, and that's it.
Okay.
If you wanted to back up,
Yeah, I can go back slightly before I go into the
we are on a zoom.
exposed to the sun, which is 690,000 kilometers in diameter.
There we go.
The same thing, yeah, and also
Okay.
Jupiter is also 69,000 kilometers in diameter.
All right,
Yeah,
stay.
funny how these numbers turn up everywhere.
All right, you are. Let's see, everybody. This is Stephen from London, the Shard Baby. He goes by on YouTube
YouTube
and at Shard_baby on Twitter.
Yeah, that's
And
me.
he has a revolutionary idea. He's done a dissertation on it. He has studied extensively on this subject, and he is about to unleash it to the world. Hopefully we can clip this, send it to Elon. Maybe they can have a conversation sometime. And you're on.
Yeah, okay, well, yeah, I'm Stephen, and, well, from London in the UK. I've travelled 5,000 miles to be here, and the first time I went to Starbase was in December. That's when I met Jessica. When she was doing a live stream. Also did another interview back then. This time I'm talking about something that's I think is quite important, because this is why I'm so interested in Starship and Starbase, is because of what SpaceX are doing. They are basically, they're the pioneers in the sorts of engineering that is going to lead us, miles ahead into the future. We are seeing a Starship, we're seeing a rocket that is a fully reusable system that is going to take us to another planet, which means that we are no longer at risk of any event on Earth that means that we can't leave the planet, which means that this is it's absolutely necessary that we're looking into this right now, and that's what SpaceX are doing. They are building a fully reusable rocket, and not only that, it's a system that is going to take us to Mars, but it's also going to help people travel around the world much more sustainably. And the thing is, it's being run on the Sabatier reaction, which is taking it's the process of heating carbon dioxide and water, and if you heat those together, you get methalox fuel, you get the propellants. So it's this really smart system that is carbon neutral. It means that we can get more tonnage to orbit. We can also transport from point to point on Earth, which is much more easier than taking an aeroplane. And the thing is, it's one of these things that's going to make a massive difference, because you see how much CO2 is being used when you're on an aeroplane, and they're also much slower. But this means that transport on Earth is going to be much easier. It's going to mean that we're more connected, so that we kind of break down the barriers between different parts of the planet, and also different parts of the universe. So out there, we're going to be able to explore. We're going to be able to see new worlds, and that's going to be it's going to be a game changer. But the thing is, I'm a structural engineer. I studied structural engineering and architecture at university, and I really like this big idea thinking. And when I was a student, there's this. Well, mostly I was taught how to design with concrete and steel. But the thing about concrete and steel is that it's what we all use. Spent most of the time learning about these two main materials that we just started to use a lot at the beginning of the 19th century. And the thing was that, recently, this is, I sort of came to understand that we were taught about timber as well, but only slightly, which was it's quite alarming actually, because timber is, of course, it's grown on the planet. You can grow it anywhere, and it means you can grow it on Mars. So if you're building a city on Mars, it's a good thing that you'd be able to grow something straight in the ground rather than bring it with you, because that's much more efficient. But also, the crucial thing is that you've got these systems on Earth, like you've got airplanes that are putting a lot of CO2 in the planet. But the scary thing is 33% of the CO2 of our planet, am I in the right place? 33% of the CO2 of the planet is generated from creating concrete, just concrete. Like 8% is made from taking the clinkers from the Earth. But the thing is, it's a non-renewable resource that we're taking from the planet, and you make it into concrete, and concrete is usually combined with steel. And when the structure goes bad, basically, it's not. You have the concrete doesn't really last as long as 100 years, 200 years. There are projects in London where things are actually made to only have a design life of 120 years. So we're currently using a material that we shouldn't be using, because it's unsustainable. We can't do this on Mars, and we certainly shouldn't be doing this on Earth, because we actually have the capability to change this round. So when I was a student, I found out that timber was very little talked about, but we were taught about it a bit. But then I found out that there are these tall buildings that are going up in Norway, but they're completely made of timber. And the thing is, as a kid, I grew up watching construction projects. I watched up seeing the Shard. So I really love tall buildings. Tall buildings are a really fascinating thing because tall buildings are pushing engineering to their limits. So if you're looking at tall buildings, basically you're looking at the structure for any type of structure on Earth. I decided, I got quite excited. I like tall buildings. I like things that are moving forward, are actually making progress and making changes. And there are things, and looking at things where we can actually make changes about things that we can change. We can change rocketry. Like SpaceX are proving that right now. We can go from we can go from a system which is using RP1 fuel to a system that is using clean fuel like Methalox, which I think I just said it's carbon neutral because basically you're taking carbon dioxide out in the atmosphere, you're burning it, and there is some energy that's going into it, but not as much as what it takes to take RP1 from the Earth, and you're extracting that, and that's never going to be replenished. So with tall buildings, I wanted to study this for my dissertation, and I looked at tall timber. I was looking at tall timber, and I was quite shocked that I think the tallest building in the world was the tallest timber building in the world was Hardwood House, and I was thinking, well, there's got to be another way. But then, I was looking at some papers, kind of put two and two together, and I found out that actually there was an innovation between the Empire State Building and the John Hancock Center, where they drastically changed the way that they designed buildings. That meant you could build that you could build quite high. And the thing is about tall buildings is that it's like the Mega Bay. And I'm going to look at the Mega Bay for an example to explain this. Is that basically a tall building is a giant sail. It's going to be You've got to design a tall building to take gravity loads, but what people don't realise is that the main constraint on a tall building is the wind loads, which are lateral loads. These are horizontal loads which are hitting the building. But the thing is, when you've got a tall building, it's basically like a cantilever beam. So if you've got a beam that is extending out of the building, and you're putting a force at the top, like if you've got a building that's standing upright, and I hope you can see this in frame, the force at the top is going to be like that force on the edge of the cantilever, which is going to be at the maximum at the top of your building, because the higher you go, the windier it's going to get, until the point where you are up in the sky and there's not so much atmosphere. But you've got a force applying to your building, and that is force times distance. It creates something called a moment. So basically, imagine a seesaw. So like this cantilever beam is extending out of the building, and the force is going down. So by physics, it's going to put a turning force on this end, the fixed end of the cantilever beam. So your building would actually try to twist over, but you've got to have some sort of restraint to make sure your building doesn't fall over. So it's actually very crucial for tall buildings to be not only designed to take the self-weight of the building, but take the force that is pushing on the building that's trying to turn it over. And I mean, I can explain this with the Mega Bay, because the Mega Bay is a perfect example of a structure which has been designed as a tall well, functionally, as an optimal structure for tall buildings, because it's expected to take wind loads. And the thing is, it can be quite tricky to transfer. You've got to have something called a load path, which takes your horizontal forces down into your foundations, because otherwise, and then those columns, so basically the structural elements at the base have got to be able to take those moment forces without those that sort of, or any sort of torsion. So you need a substantial, something substantial enough to make sure that your horizontal forces can resist those horizontal forces, basically. So the challenging thing about timber is that it's made of trees, and timber is just like a tree. It's engineered timber, so you can actually layer the veneers of the engineered timber material, so it's actually stronger. It's tree. It actually turns out that timber is very good in one direction, but it's not very good in the other direction, because it's an isotropic structure. So it's very strong in one direction, but it's not as strong in the other direction. So basically, you look at a tree, it waves around, which is a massive problem when you've got a skyscraper, because you're designing something that's like a tree. So this. You look at these together and you just think timber and tall buildings just don't go together. But actually, there's a way to do it. And because basically you need to have a structure which can take those horizontal forces and take it down vertically. So your horizontal forces had to be transferred efficiently, which is quite tricky, because you've got to take the axial strength, it's the strength which is, if you've got a structural element like a square column, your most optimal designed column for structural efficiency, efficient use of materials, would be going straight through that material. So each structural element is going to be working very well in one direction, but you've got a tricky thing where the horizontal structural element is meeting the vertical structural element, and this is called a moment frame, because it's what you see at the top of the mega bay, where you've got very rigid connections at the node points, and the node point is the point at which structural elements meet. But the thing is, the node's got to be very rigid, because you've basically got horizontal forces that are 100% horizontal, but they're also 0% vertical, which have then got to go to be 100% vertical and 0% horizontal, because otherwise you're stressing your structural elements. So that's how the moments are very strong at those node points, and that's how the mega base structure works. Is that steel is very good at this, except of course you've got to work with timber. If you're going to be working with timber, there's actually only really one way that you can, or one way of seeing, or you've got to take advantage of that favourable stress in the parallel to grain direction, because the parallel to grain direction is the natural structure of the wood which is strongest. Perpendicular is not the best. So if you actually look at the mega bay, what you've got behind the structure, and I made a diagram earlier in the year, because when I was here last, Jessica mentioned. Well, I was talking with Jessica about making progress drawings, because I made progress drawings for the shard ones going up, as in progress updates. But I really enjoyed doing that as a kid, because I like to see the way things were being constructed and way structure works. But yeah, I've done a diagram now of the mega bay structure, because I've been doing progress updates for that. But But you can see that in the mega bay structure, you've got these sort of frames, which are like moment frames, but you've also got these things called braces. And okay, let's just call them mega braces because it's the mega bay. There's also a building in London called the Lenhill Building, which also has a very similar type of structure. It's my favourite building, one of my favourite buildings in the world, basically because it has to be braced on the outside. But the thing, the bracing is the solution. And I looked at the Empire State Building. That's a moment frame. But the thing is, the John Hancock Centre and these buildings in the 1970s, this big innovation, this big step forward, used this bracing system. And I kind of put two and two together, and I realised, hang on, if you apply this to a timber, it's sure it's going to work because you're making the structure more efficient. And the reason why that works is because when you have a brace, you have a horizontal force hitting the building. But the thing is, it's then transferring into that brace, which means that if you've got at the efficient node point, that force is going horizontal, but it's also going vertical. Because if it's 45 degrees, like the mega bay is, just an example, you've already got 1 over root 2 times the force, the lateral force, which is like wind loads and stuff, which is going down as well as across. So that can be in tension and compression, or it would be in tension when the wind load is hitting directly. So you've got a load path which takes your horizontal force down through your brace and down into your foundations, which is amazing because this hadn't until I did my dissertation, nobody had tried to make a tall timber building above 300 metres. The thing is, I studied this from my dissertation. 300 metres is 1,000 feet basically. And okay, there's in tall buildings there's a category called super tall, which is between 300 and 600 metres. And I thought this was a good idea because tall buildings are pushing engineering to their limits. Because you have those higher wind loads, which is the perfect way to test timber, because the challenge is getting that horizontal force down vertically. So you're actually trying something and pushing it all the way up to a number. Nobody would have really thought to do this, but I really like tall buildings, so I decided to do it. Up to 600, yeah, and basically I came to this conclusion that this structure, that this similar type of structure they use for steel, works really, really well with timber. But the advantage of it being a tall building is that, as I was mentioning with transports earlier, yeah, I hope this all makes sense because I'm saying lots of things.
You're doing great.
Cool.
Everybody, let's give some love to Stephen in the chat. You're doing great.
Yeah,
Keep going.
Thanks so much. Yeah.
You do have some questions, by the way.
Oh, that's cool. Yeah, I'll answer the questions. Yeah, but like you've got, the thing is, transport uses a lot of energy, and the good thing about what SpaceX are doing is they're making leaps to make traveling around the world more energy efficient, and that's you're going to have to be extremely resourceful on Mars. So SpaceX or Elon Musk and his companies, a lot of very talented engineers, they're doing these projects like the boring company, which fits the tunnel boring machine fits inside the payload bay of a Starship. Which means it's designed to be transported to Mars, because the idea is that when you're on Mars, you'll need to set up a transport system because you want to get from A to B, from city to city. But the thing is, that's kind of really efficient, because if you're in a city, the difference, well, one thing I've noticed is the difference between a skyscraper and America, because America's a perfect example, because you've got, so everything's really spread out. And because everything's spread out, you have to transport from place to place. But the thing is, that's a lot of energy. That's a lot of you're using resources. You're burning resources to get from place to place. The thing is, you've got to create something that's much more sustainable because you've got to survive on the red planet. Red planet. SpaceX are creating a system where the Starship is the solution for long distance travel between point to points on Mars, and Hyperloop is a short distance. But the thing is, ideally, you just want to keep things. You don't want to be using so much resources when you're building your colony. So the best thing would be to keep everything in one place, so you don't have to spend so much energy traveling around. So the skyscraper is the perfect example of creating a place that's sustainable, because you don't have to travel from. You don't have to spend all that energy to travel. So basically, if it's all in one place, it's just a vertical city. So like your shops could be on level 50, your farms could be on level 100, or probably organised a bit more efficiently like that, so that you have like farms at the top, so that's where so people don't have to travel up so high. But the thing is, you can grow trees on Mars. So you don't have to bring the resources to the red planet. And the thing is, something I noticed about the Mega Bay is that and this might not be true, so this is just speculation, because I just noticed it the other day, is that the structural elements on the Mega Bay are, I think they can actually fit those inside the payload base. So you could actually build a Mega Bay on Mars. So there's this thing called modular construction, where you prefabricate parts and you just stack them, and I guess it's going to be much more efficient to stack things like the way that you've seen the Cape Tower, and I've also been doing progress diagrams for the Cape Tower, and you'll see I can do a quick frame animation of that, just showing like how when you stack it, you're basically building.
And you will do this.
Yeah.
No promises.
No promises. I'm doing the time lapse for the Mega Bay for sure.
Do your thing.
Yeah.
I just want to pause you here real quick.
Yeah.
Okay. We've got a lot of people that are following along. A lot of people that don't understand anything that you're saying, which is okay.
Okay.
Okay. You're doing great.
Because I'm saying a lot
I
of
want
things.
I want to ask first question. Okay.
Okay.
If you could ask Elon Musk or propose him one sentence.
Okay.
About what you just said.
Yeah, that's a good.
You can do it. Big paragraph. Go. First thing out of your mouth.
Sentence.
Or out of your brain.
You can build. Yeah, you can build. Would it be good to look into creating? Yeah.
Yeah.
So
roll with it.
Would you be interested in looking into using timber to create? Okay.
You got it.
I think. Yeah. Would you be interested in looking at renewable materials like timber, which you can grow on Mars, to create modular structures which use less resources? Okay. Would you be interested in using renewable materials to construct modular structures on Mars, so that you don't have to bring so many resources with you when you go to the red planet?
Yes.
I think that's a summary. I mean,
that's good.
lots of structural engineering behind that.
I'm Elon Musk. Yeah.
That's
what I'm Elon. I just said, yeah.
Cool. Yeah.
Now what?
Okay. Now what?
We called it an elevator pitch in business school.
An elevator pitch. Yeah.
You have the time of an elevator ride with him.
Yes.
Could you explain it in an elevator?
I could do that. Yeah. So basically, the advantages of okay, I looked at this for my dissertation. The advantage of the timber is that it's very strong in one direction, but it's very strong in the vertical direction, not very good in the horizontal direction, which basically means that you have to be very creative way that you design it. But the thing is, if you look at the Mega Bay, you've got a tall building which has got to have a lateral load resisting frame. So you've got to take the advantage of the axial strength, or the strength and the direction of the timber that does work. So ideally, you want to be creating a sort of structure with a lateral load resisting frame, like a brace tube or a diagrid, the thing about timber is that you can replace it, you can renew it.
You said you can send it in modular.
And send it in modular pieces.
We got a lot of, come on, Shards. You got this, Shards, and you got it. You got it. Elevator's still going. You guys are going all the way to the top of the tower.
All the way to the top, yeah.
You guys got it. How is it better than steel? How is it better than concrete?
The thing is, it's just like, it's like the projects you're doing, because the difference is that you're making a system that takes, is going to make things better for the planet. So why don't we build with timber? Because timber is basically carbon neutral. You're going to have like near to zero of the amount of CO2, compared with the 33% that you're creating for concrete. And 33% is
getting close to the top, getting close to the top.
Yes.
You're doing good. So what I took from that is it's renewable.
It's renewable, yeah.
It uses less carbon emissions. You can take it in modular,
yeah.
and it'll fit inside the Starship.
It fits inside the Starship payload base, so you can actually construct these structures like the same way you build in the
And you said that you can grow trees on Mars?
You can grow trees on Mars, so you don't have to bring so many materials with you.
There you go.
Which is the disadvantage of transport, because when you're transporting stuff from city to city, you're using a lot of resources. Just doing that. So skyscrapers, I think, are the optimal way to build a Mars. So I'd really recommend looking into it, because
boom,
you do. It will make a big difference to what you're doing on Mars, and also a big difference to what we're doing on Earth. Because this is the thing: is that it's like what Elon did with Tesla. Was basically that is that at the beginning of the 19th century, we just had. We had the chance to innovate with electric vehicles, but we kind of forgot about that. And there was no innovation for like 100 years. The exact same thing happened with concrete and steel. We decided to choose concrete and steel over timber and stone. But the thing is, now we've got to a point where we can design engineered timber with, which can take the loads of a skyscraper. And hey, I did it for my dissertation. You can see that. Yeah, you've got all the proof. Feasibly, I've got the data.
Will you take questions?
Yes.
Before they scroll off screen.
Okay.
All right. Good job. First of all, holy cow.
Okay.
Do you feel like you got everything out? Do you have anything more?
I could say a lot.
Okay. Let's go to questions though, real quick. Okay.
That's good.
All right. We got 81 people still hanging out. Let's see here. All right, Michael Nettle asks, let's see, where'd it go? Hold on, pause. Where'd it go? Sorry. Where'd it go? Okay, for Shard, is the large percentage of CO2 from concrete because the process is inherently CO2 intensive, or is it just because of the large scale use of concrete?
It's kind of both, but very much the process in which you make concrete, because basically it's made in a kiln. Stuff that's happening in a kiln isn't good for the environment. It's not good at all, because you're basically heating stuff.
What about the baking of the tiles?
You're heating stuff, superheating stuff to really high temperatures. And also when you burn the clinker materials, it releases a lot of CO2 in the planet just doing that. But the thing is, and the same thing happens with steel. I mean, you need some steel to make timber buildings, because you need to have some reinforcement around the node points in order to make sure the load efficiently transfers between the structural elements. But yeah, it is both, and also it's not only the CO2, it takes a lot of sand, and sand's also not a you can't replenish sand on the Earth as well. So it's because we use so much of it.
So it's a quantity thing.
It's a quantity and it's a process.
Okay.
So if you replace that process with, say, grow a tree, it takes.
I wish there was a guy who was like an incubator for plants to travel. He was in the chat a couple weeks ago. Anyways, Tommy, do you remember Tommy?
Yeah.
Tommy from Germany is in the chat, and he asked, how would trees be grown on Mars? A big dome building with compressed atmosphere or something?
Yeah, you could build it in the buildings. You could build it in a skyscraper. You could build a vertical farm with inside a tall structure. Yeah, it would just. I mean, we haven't tried it. That's why it was an experiment to try the first tree on Mars. You can certainly stack some Starship. You can cultivate you can engineer an atmosphere from what they have on Mars. They have O2. They have, crucially carbon dioxide, so they can photosynthesize. That would happen at first, but eventually you'd have enough in the atmosphere to sustain growing them out on the Martian landscape. Yeah.
Let's see. Good job. Let's see. We have lots of questions about timber.
Okay.
I have a feeling that Stephen is going to need to create his own videos about this kind of stuff sometime. No promises. Yeah. But going into depth about this stuff, because we have a lot of questions that are asking very specific depth stuff.
Okay.
So I'm just going to give you all his YouTube channel.
Okay, yeah.
And
ask me a question on Twitter.
Yeah.
I'll eventually answer it put it in a YouTube video. Because I was actually going to explain how the Mega Bay works and how the launch tower works.
Yeah. Boom. Everybody go subscribe to the Shard Baby on YouTube. Also follow him on Twitter. Ask Stephen questions. Any questions on Twitter? Good job.
Yeah.
I
think I could say this. I could say this all in one go about. Yeah. As a sort of summary of all this kind of Yeah, the launch tower, because basically the launch tower is the same system that I'm proposing for, it's a similar type of system that I'm proposing for timber, but the thing is this has never ever been tried with timber before. Because basically the Mega Bay can take horizontal loads, and the thing is you've got all the loads going into one point in the building, because it will just be hitting one face. But the thing is, you want to evenly distribute that around the columns. You want to evenly distribute that around the columns, so you have an outrigger structure, which is a structure on the outside. I can explain this in another stream, I think, because then I'll be able to say everything in one go.
There we go.
Yeah.
All right, everybody. Thank you so much. Fist bump.
Yay! Thanks very much.
Good job, Stephen.
Yeah.
This is Stephen, everybody, the Shard Baby. Yeah. Hi. Let's see. We've got youtube.com/theshardbaby, and then.
Oh yes, I'm redoing a website at the moment.
Oh yeah.
Yeah.
You're redoing.
I'm remaking my website.
Websites are the hardest thing to keep up with.
And then you get the
Danny.
template. Yeah.
He talks like Elon does. Mind always working things out. He's got a brilliant brain.
Yeah, I was thinking of a lot of things at the same time, because there are lots of parts to this. There's of course what SpaceX are doing, which is making. I could probably say this in I could probably say this in another interview just to summarise all of the
Do you want to?
stuff. Yeah.
Okay. Should we go back to the?
Yeah. To the site. That sounds good.
Okay. You want some water?
Yeah, I'm fine.
Yeah. All right, everybody, give some love to Steven in the chat. He is a wealth of knowledge. I'm serious about asking him questions and.
Actually, yeah, because I think
Oh, look at them.
if I put if we put the interview in a video, I think I'd be able to explain it.
Okay.
Yeah, I could probably explain it.
What about yourself?
Yeah, it's fine. I could probably explain it a lot better then.
You did pretty damn good, darn good for just, hey, you want to do an interview?
Yeah.
Talk about thinking on your feet.
It is. That's yeah.
Can we have a timestamp, everybody?
Timestampage.
Timestampage. 5:08 p.m. Good job, dude.
Yeah.
Proud of you.
Those are some just throwing that out there because the more that people know about that. Oh, thank you very much. Yeah. More people know about this.
That's right.
People are looking to SpaceX. I mean, because there's a thing that's basically lots of construction companies, concrete companies, kind of they say they're sustainable about concrete and stuff. But yeah, this isn't talked about because it's pushed out of continued professional development sources. So if you're actually an engineer and you're trying to learn about this stuff, you're not being taught it properly, or you're not unless you decide to do your own study. Which is why I decided to do it for timber. Yeah.
We're really honored to have you.
Oh, that's good. Yeah.
On the stream, and for sharing your knowledge.
Yeah.
And your passion is contagious, and you're clearly a wealth of knowledge. I mean, people are just going.
Yeah.
They're going on. There's 69 people in the chat right now. Woo. 1 hour 45 minutes. Thank you so much, Nick Level.
How long was I there?
That's the timestamp. That's the timestamp.
Yeah.
Okay, I'm gonna do 1 hour. Thank you so. 45, and that will be.
Hey, yeah, what?
Wrap of Steven's.
Yeah.
Interview.
Help us build, yep.
I think you have some stuff to talk about on your channel.
Yeah.
No pressure.
Yeah.
The best thing is you have a platform.
Yeah. Because. Yeah, I can.
Drink some water, please.
Yeah.
I'm gonna. Good job.
There are lots of things to say about. Yeah. I could probably do an interview and then I can tie everything together.
Okay.
If I actually kind of think about it.
I want you to have your visuals with you.
Yeah. My
like
visuals.
your computer. And,
yeah.
Or maybe we can project it or something.
There's something because
maybe something in the pavilion at Rocket Ranch or something.
When I explain the Mega Bay.
You would be such a great college professor.
I just drew it on like Snapchat and like because it's a lot easier to explain how the Mega Bay works.
I feel like you'd be a really good educator.
Yeah, you'll get that later, everyone.
Y'all, you'll get it. Did you hear that? Was that a promise?
Yeah.
That was a promise.
Yeah, I want to talk about that. Yeah. Yeah.
Thanks, Andy.
Because the thing was, I started doing Mechazilla at the beginning of the year, and it like took 3 months to do that. It was the other, and then they stacked the first segment on the Cape Launch Tower on the 21st. But the thing is, it took so long to draw the pipes in and stuff.
People need to see what you're talking about in order to...
Yeah,
like,
so if you want to find out how much work it went into, go onto my Patreon.
That's right. He's got a Patreon.
Just started it. You can donate anything.
Donate anything. I started with $2.
Yeah, thanks.
Which I promised that I said that maybe there might be some months where I might not be able to. Which is with all my Patreons, as Bill's still got to get paid over here.
Yeah.
But patreon.com/the Shard Baby?
The Shard Baby, yeah.
Is it that or?
The Shard Baby, yeah.
The Shard Baby.
Yeah, because I'm. Yeah, that goes into equipment and so on. Because I mean, I've just got a camera for Starbase, and it's just a simple camera.
You're doing good.
But yeah, on Patreon, I've just shown a diagram which shows all the bits and pieces that you can see. lots of stuff I was working out in order to do the first drawing with the stacked tower segment, and then it took until the 30th actually, because then it was by the time that the third segment.
Are you putting how much time it's taking you and all that stuff in the description? Because you should.
Oh no.
I'm just saying, it's a lot of work, but
it is.
You should.
I modelled the chopsticks this year.
Yeah.
Yeah, that took time.
We've got some dots coming in,
hey.
but you should go, before the chat moves away, you should see what some of the questions were and think about how you can answer them.
Yeah, because
But let's go quiet just for a little bit, just to have some, only because. Yeah. Let's just go, we'll go quiet for a little bit. Everybody, I'm going to turn mics off and just give some quiet just to watch what's going on here. And we'll be back, okay? We love you all.
Thank you. That was sort of bouncing between lots of things.
I thought you were doing great.
I know when you're. Of course, people can't read the mind, so.
I think you did a really good job.
Okay.
And I think that you should take a deep breath.
Yeah.
And just say, I did a good job.
I did a good job. Yeah.
And it's buzzing in my ear and the mic is off. So I don't know why it's buzzing.
That's not. Okay, I'm just going to say, if you're okay with this, that's not really the final one, because I can say.
Oh, hi, we're back on the audio, I forgot. Hold on. allergies. Oof. That hurts.
It's funny it's doing the snappy thing.
The what?
I was doing this, it's funny I was doing the snappy thing, so I thought it was the, yes, I thought it was doing this. Like it's like
How are you doing with it?
I was doing like this.
Oh yeah. Well, that makes a noise.
Yeah.
Yeah, it's okay.
I thought it was snapping like that.
Thank you for hitting on thumbs up button. So. Sweet. Yeah, it's very nice. I have a bucket. Thank you. I feel you. Oh, here, yeah, thank you.
Yeah, that's right. Yes.
It's rolling.
Thinking up multiple things at the same time.
I can hear the grackles. Crackle! Every day we grackling. This branch kept swaying in your face.
Yeah.
And then I would try to bend it up without breaking it, and it's got thorns on it.
Yeah.
You're strange.
Because I was thinking about one thing, and I was thinking about I was seeing the it's like that's happening over there. That's there is that one.
Everybody double check your resolutions. Everybody double check your resolution. YouTube keeps putting my resolution down to 144p. Grackles be crackling. Thank you, what? Thank you, moderators, so much. Sharp Baby is actually one of our moderators. Thanks for putting the fire barrel in there. But no, thank you, thank you.
If you're wondering how we get the heart,
Oh, yeah.
it's if you join as a member,
If you join as a member.
you get access to all these really cool emojis.
That's right, thanks, Sharp. Thank you. Oh yeah, those are all the channel emotes. Alright, let me...
Yeah, Moon Bruce mentioned something quite important. That's with my background in wasteable plants. It takes Moon Bruce pointed out something quite important.
Oh wait, sorry, not plugged in yet. Oop.
Robbie's
Alright.
cool.
Go for...
Yeah, Yeah, because Moonbeam Bruce said something that's quite important. I'd say probably say when I explain this, I'll explain. Do this. Well, planning to speak about the Mega Bay and the launch tower, and I'll kind of do a wrap of what I said in the interview, basically. Yeah, because
what did he say?
What did he say? Yeah. This is me thinking of several things at the same time and
let me look.
getting distracted by thinking of something else. But yeah, he mentioned that background. He has a background in wafer-board plants, and it takes 20 years to grow a reusable tree. That's a type of hardwood. Thing is, engineered timbers are made of softwoods, and softwoods only take 2 years to grow.
Softwood, okay. Yeah, like pine.
Pine, yeah. So if you construct everything out of softwoods, it's possible to make it sustainable because you grow enough trees. Yeah, I'll make sure I mention that because thank you, Moon Bruce. That's good.
Danielle Elliott mentioned bamboo.
Bamboo, yeah. And
Les Brown, my favorite motivational speaker, in the same speech that I listen to all the time, he said, in the Far East, and it's east of the U.S., the Chinese bamboo tree takes 5 years to sprout. But at any time in that 5-year period, if the gardener or the person who's planting them stops watering them, the tree will die in the ground. So he says, will the bamboo tree, how long does it take to grow the bamboo tree? Is it 5 years or however many months? It's like 3 months or 4 months or something to sprout 90 feet tall. And the obvious, he said the obvious thing is that it takes 5 years. But when I thought about it, I was like, no, it takes a couple months. No, because you have to water it and water it and water it over 5 years. And then it sprouts 90 feet tall and is 4 months.
But the thing about bamboo is it takes a lot more water. It's like an avocado plant takes up a lot more water than bamboo. So the type of timbers that you'd be building for tall buildings would be much more energy, much more efficient. But yeah, that's a good point. You need water.
Let's see. Sorry.
Yeah.
Conversation between the Stevens.
These are good comments. 2 + 2 is 22. Yeah.
That breeze feels nice.
In a jungle climate.
Yeah, in a jungle climate. I don't know.
Two years. Yeah, 2 years to grow pine. When I've read somewhere. I'll make sure I double check that I read somewhere that it does take 2 years, about 2 years for softwood to grow, because that's how that. Yeah.
You're meditating.
That's good.
Max Q. Understood. Automatically logged out. What? Hold on. Okay. Look again, please. Okay. All right, if I could find out what's going on there, and maybe
Ah.
Did you get? Yeah! Oh my gosh! That's awesome. We should show some views of the river. Let's do that.
Yeah.
All right, y'all. River time, doot doot. River time, doot doot, doot doot. There's some cumulus towers also on the horizon. All right. Zooming out, we are at the Rocket Ranch Outpost, where the views never, ever fail to impress. We're looking at the Rio Grande River. This is the border of the United States and Mexico in the southernmost southern tip of Texas. I'm going to... Oop. Get out of there, you freaking mosquito. Jerk face, McGee. This is the outpost, y'all. Here we go. All right, we're gonna go this way. Oh, there's grackles in the tree. I'm a grackle. I'm a grackle. Every day we grackling. Oh, they're mating. Oh, they're getting busy down there. They're getting busy. I'm showing it. I'm showing it. Grackles be mating.
Oh no.
Oh, here comes the third one. Ho, ho, ho. Oh, that's a mama grackle. Maybe there's a nest down there. What are those bushes?
What are the grackles thinking?
That's a really good question.
You
What
got a
are
long
they
lens.
thinking? Do they think they're being peeped on?
Yeah.
Look at that, look at that. Ooh.
Okay.
Oh, there's a spider on that. Here we go. We peeping.
I mean, it's been covered slightly by the.
Look at the grackle. Oh, this looks like a baby. Oh, look at the grackle.
I don't think we can say that.
I mean,
Okay.
you're moderator. It's up to you.
Yeah, I know. I know.
Oh, but they're eating the berries on the bush or whatever that is.
Getting a lot of it.
Yeah. I heard that they moderate their heat by opening their mouth.
Yeah. Thank you, being what?
There are a lot of them. Grackles are fascinating.
Actually,
There's one. Ha! Hello, Mr. Grackle. Wow, that's a beautiful shot right there. Holy.
I don't think you've seen this before.
I'm a grackle just sitting in the bush, regulating my heat.
Yeah,
Regulating my heat. Looking for treats.
like never seen this in the wild. This
No?
is- yeah.
Oh,
I
look.
think
Oh.
this is the first.
That's cool. There sure are a lot of them over there. I like it. Ooh, yeah. It's like GrackleCon.
I'm a grackle.
GrackleCon. They are really fascinating birds.
I'm a grackle. Right.
Grackles be grackling. What you doing down there? I want him to pop his head up. Boop. Boop.
Wow.
Huh.
Wow, you got a really good shot there when
Oh,
flying
cool.
past.
Flew away. Thank you, Jimmy Lens.
Crackles be crackling.
Crackles be crackling. There's one in the tree right there. I'm just a freaking grackle. Give us his tail up. Foom, foom, foom.
Je suis un grackle.
Je suis le grackle.
I don't know much French.
Oh, there's two.
I'm sorry, I
Oh, look
shouldn't
at
say
that.
French.
Don't be sorry. It's okay.
Yeah, I'm just not good to copy people's accents. Too much?
True.
Yeah.
And I do try to do a
Yeah.
British accent, but
Oh yeah, yeah.
I'm not. Oh, what did they get? We're looking for the. We're on Grackle Cam, everybody.
Grackle.
Grackle Cam.
I'm a grackle.
There he is. Oh, popping out. Oh, yeah. Oh, wow. He's walking on sunshine. Oh, I'm walking on prickly bushes. Whoa. And it feels so good. I'm a grackle. I'm a full-grown male grackle. That's a female. That looks like a baby female. Look at that guy. Oh, is that so? Sorry, I'm so high pitched. They're so funny. I wonder what he's thinking. Food? All right, we're gonna go this way. Over across to Mexico. By the way, there is a pizza oven here at Rocket Ranch. You're seeing it right before your eyes? Right there.
Yeah, I had pizza there the other night.
It's delicious, isn't it?
When you were streaming over
Mm-hmm.
all the fireworks.
Yeah. All right, let's look at the birds.
And then great thing about Rocket Ranch is they have a boat.
Mm-hmm.
And you can go. They take you. Yeah, they'll take you here to the outpost when there's a launch. Yeah, I lost my SpaceX cap. It blew off in the wind when I was on the boat. So
We're looking at seagulls in Mexico. I'm a seagull. Oh, lots of grackles over there. Holy grackle city. All right. And I'm going to go through the trees right this way. Thank you. Where's the water? There it is. Through the trees. There is the Rio Grande River. Put it on manual focus. Relaxing. Booty. Another booty. Oh, fencing.
vintage.
Vintage.
Is that vintage? Where's where? Is that?
On the tippy toppy of the GSC tanks on the left hand side.
Oh, that's good. That's the smokestack. Or the pipe stack, whatever you're calling it.
I don't know what they're calling it. Vintage. Oh, cool. Wow. He's swimming and then flying into the wind. Oh, that's so cool. And he's out of there. It's like waves. I can hear the water, it's nice. It is a really nice day. Oh wow. I did birdie. Sorry for moving the camera, everybody. It just is what it is. So my friend that builds drone ground control stations gave me that.
Oh, this?
He has like all these bins. He has obviously a business, but all of these bins hanging on the wall, plastic bins, and he was just like, "Here, have some." And put them in a little baggie for me.
Yeah, these. I've seen these before because I was trying to build a sort of portable, not a sort of Raspberry Pi thing, but a sort of portable computer at one point. But yeah.
I have a Raspberry Pi.
The idea was a bit. It was based on technology that didn't exist yet.
That's the best kind of idea to have.
Yeah.
And then you have to invent the tech. You can do it.
It's yeah. The storage was okay.
Yeah.
It's just a matter of doing something that's never been built before.
Right.
Like, yeah, that's kind of a dead end.
Nah.
Not a dead end with the resources I had.
Right.
Well, I had loads of projects I was working on at the same time. No, nothing's ever done. Like a Starship.
Yeah. Everything is evolving. Faux show. That's a beautiful bird. Booty. There he goes. They walk so slowly. Their long legs. I assume that you're finished with this?
Yeah.
Okay.
That's my
Here's this. Why does my head hurt? Well, I'm wearing prescription that's out of date. That. I haven't eaten more than the Whataburger and
what's in shot right now.
That's cool, right?
Yeah. Looks like a stork.
Yeah, they were talking about it in the chat, trying to figure out. Oop. Oop. There you go. Range. Oh, yeah. See if we can get him to crawl through to the other side of the frame. Ooh, I just got dizzy standing up. I need to... Where'd he go?
Yeah, it's oh, I'm just reading back at the chat. It's really good stuff that's being said.
Chat's awesome.
Tommy said Mars architecture is going to be awesome, much better gravity, so we can build much larger buildings. Yeah.
6 o'clock.
Yeah,
Crazy how fast time flies. What'd you say?
Because the gravity is smaller on Mars, so therefore you're designing less for gravity loads. But the thing is, what you'll be aware of is that your building is being hit by storms. They're strong storms, but the storms are only 1%. The atmosphere is only 1%. So you got to know that. Actually, that's something I should look into. I'd ask you on that.
There we go.
Yeah. Because, yeah, that's what I was trying to say, is that tall buildings are sort of more governed by wind loads and natural loads.
Oh. Don't mind the stuff on the other side in Mexico. Trash and all that other stuff. No big deal. We're bird watching here. Thanks, Pia and Wet. Got a load of them over here.
Oh wow.
Alright, we're going back this way. So many grackles, your brain's gonna blow. Oh, there they all go. Grackles and the ship. Here they come. Got 'em. They're all on the tree. I'm a grackle. I'm a grackle. We just be grackling.
It's just my automated response now.
Grackles be grackling. That's good.
Yeah. It's quite funny though, when I'm at home and like watching your streams.
That's right, your mom said, you want to go hang out with those crazy people?
I'll just randomly say, I'm a grackle. Then eventually I showed her the highlights.
Mm-hmm.
The ones for the...
Ooh, that one's really pretty. Ooh.
And then she kind of finally knew why.
She understood.
Yeah, she understood. Look.
Did she see your interview?
No, she hasn't seen it yet.
What?
No. So I was at my grandparents' house when it went live.
Mm-hmm.
It went
Okay.
the
premiere
was released.
Mm-hmm.
So I was like, yeah.
I understand. Grackles be grackling.
Ooh, chopsticks.
Let's go take a look. Got some vintage. The lighting's getting a little better, which is good. Oops.
Wow. Okay. Have you seen the shots that SpaceX have shown of the booster? And
I have not.
yeah.
Are they cool? Which ones?
Yeah. SpaceX have just posted them.
Oh, cool. Ooh, cool. We're in the background. Hello. Yeah, it's beautiful. Dronage.
Actually, yeah, dronage. Actually, I might be in shot somewhere.
I always like to look for the Kona.
Yeah, because hey, it's me. Yeah, I'm next to the
Let's see.
gate. Yeah, I'm there.
Cool.
Yeah, like the entrance to the car park where the palm trees are.
That's cool.
The site's looking much cleaner now. That's amazing. I'm going to share that in the stream.
Do it.
Crackles. That's funny.
I'm going to sit. Give you this stuff. You mind if I get right behind my...
Yeah. mentioned we need somebody reliable in the because you know what's happened? So there's been some big resignations
Where?
next to like in government in the UK.
Oh, let's not talk about it.
No, okay. That's cool. Yeah, that's okay.
Here, any kind of politics.
Yeah, I don't even want to talk about it either.
There we go. Thank you, Gabrielle, for that $50 on Venmo for tacos. Heck yeah, thank you. Wow. Woo-hoo. They need someone reliable as PM, Prime Minister.
Yeah.
Stream Hellman's tweeted my tweet. That's funny. Oh. I'm so hungry. Oh, so hungry. I haven't had a meal today, but that's okay because I've got no food at home. So
I just had cereal bars for breakfast.
yeah.
I had 5 cereal bars.
Woo! There's some big cumulus clouds coming over us, y'all. Oh my gosh. Jessica Kirsh. Yeah, cereal bars.
Yeah.
Yeah. Yeah.
So that means I've got 51 cereal bars left and 27 packets of rum.
Nice. We're still live. Sorry? It's on. Where's my mic? Oh, it's up there. What's up? Oh yeah, for sure. Oh shout. Yeah. Thanks for hanging.
Great to meet you. Yeah.
Oh, you should. Yeah. Oh, no, please. I love when you have people stop. I'll open the gate for you.
Great to meet you. Yeah. See you around.
All right, y'all, I'm gonna wrap stream. I guess the road is open. Thank you so much, moderators, for hanging out. Thank you, channel members. Thank you, everybody, so much for hanging out on this stream. Shout out to Shard Baby for helping me guest host, and also for doing an interview, sharing his ideas. And we're coming to you live from Rocket Ranch, the Outpost. Yeah. I was just about to say I'm going to go home and cuddle with Stella. Huh. I'm not going to do that, but because she's not here. Anyways, if you enjoy this and want to support the channel, you can on Patreon and through PayPal or Venmo. And that's a wrap. Jessica Kirsh here. Love you all. See you on the next stream. Bye.